Hello and welcome to another video. This time it's from the Mechanics 2021 paper, question 4, and it was a projectiles question. So let's have a look at this. It looks like a fairly typical kind of projectiles question. Nothing really unusual about that diagram. It's landing below where it started, so make sure that y coordinate is negative from where you started. But otherwise it looks like it's all pretty standard. Okay, tan alpha is 5/12, so quick little diagram with alpha there. Tells me that's opposite and that's adjacent, and therefore Pythag tells me that's 13, and so sine alpha is 5/13 and cos alpha is 12/13. That kind of prep work in lots of mechanics questions is really useful to do right at the start. Other thing about this question, bold, G is 10. Don't like it when they do that, really, or at least I just wish they'd. I suppose they'd put it in bold, so I can't really complain. But why change the 9.8? Is there really much improving other than people reading the question carefully, which admittedly I don't do. So maybe they're just trying to catch people like me out. Okay, so the way I like to start these, we're trying to find the time taken to get to A. Well, let's just write down what we know. U is 65 cos alpha, 65 sine alpha, and that of course we can work out because 65 times 12/13 is 60, and 65 times 5/13 is 25, I think. A is going to be 0 minus G, but G is 10 here, so let's write minus 10 to remind ourselves of that. And then S, I suppose we sort of know where it lands, don't we? So we'll put down S little x like I often do for when I don't know a particular component, like S little x, V little x, etc. But I do know the Y component is minus 70. Okay, and then I'm going to try and find the time when it gets to A. Yeah, find the time taken for this time to get from O to A. Okay, so let's do it. We're going to obviously use that. S equals ut plus half at squared looks good. So minus 70 is going to be, now we're using the y components here, 25t. Half of that minus 10 would be minus 5t squared. And so we've got 5t squared minus 25t minus 7t equals 0. Well, that's t squared minus 5t minus 14 equals 0. So t minus 7, t plus 2. So t is 7. And so the time taken is 7 seconds. Okay. Find the speed of the stone at the instant just before it hits the ground at A. Okay, so we've got to find the velocity this time, Vx and Vy. So same as before, really. U is 60, 25. A is 0 minus 10. T, we can use 7 now, because they want the same time, this time just as it gets to A. And V is therefore equal to U plus AT. And if we do that all in vectors, we get 60, the x component, and that's going to be 25 minus 70. So I guess that's going to be minus 50, minus, oh, careful here. It's going to be minus 45. Yes, good. Sorry, I had to. And then, yeah, that's all that done. Cool. I should have probably written it down. It would have been easy if you can see what you're doing. Like sometimes, you think not writing things down is actually actively punishing yourself for no good reason. So yeah, okay, cool. Let's carry on going. Speed of the stone. So speed of the stone, we just need to use a bit of Pythagoras. And so we get 60 squared plus, put them minus 45 just in case they're really stingy on the marking and want to see that, plus minus 45 squared. I wouldn't have thought so though. I always think it's surely fine to turn a number positive when you're about to square it. 60 squared, I'm just keying it into my calculator and squaring the answer. And I get a lovely answer of 75, which makes me think I'm probably doing it right. Okay, cool. And that's that one. One limitation of the model is that it ignores air resistance. Yep. Okay. State one other limitation that could affect your answers. Well, it's the same thing every time, isn't it? Dimensions of stone. Take the dimensions of a stone into account. Or the spin. Yeah, the other answers they'll accept are things like you've used an approximate value of g, so you can make it more precise. The dimensions could affect the spin of the stone. G is assumed to be constant. Well, actually, I don't really accept that. Surely G is constant. When is it really fluctuating that much? Uh, Depends, I suppose, on exactly how you're traveling. But okay, cool. That's that one done. Best of luck with your revision. Keep up the good work. Bye bye.